Welcome to Ask and Learn.
So there is an elevator which is falling, and the work done. So we have this elevator is falling, and in this elevator, the elevator cable breaks, so it just falls. The mass is 920 kilograms, and the elevator cable breaks when it is at a height of 24 meters above a huge spring. So there is a spring here, and this is 24 meters. So they say the work done by gravity on the elevator just before it hits the spring, just before it hits this point. So work done by gravity on the elevator just before it hits the spring is negative of the work done by gravity, which is equals to U1 minus U2, which is basically equals to mg y1 minus y2. So it's 920 times 9.8 times 24. So that should give you 2.2 times 10 to the power of 5 joules as the work done when it falls. It's just mgh. And gravity is the only force. Gravity is the only force doing work on the elevator, ignoring friction. So this result is also the net work done on the elevator as it falls, basically. Now, the B part of the problem is speed of the elevator just before striking the spring. So we know that the work done by gravity is equals to the change of kinetic energy, which should be equals to half mv2 squared. So work done by gravity is mg y1 minus y2. Now this y1 minus y2 is 24, we know. That should be equals to half mv2 squared. So therefore v2 is equals to square root of 2g times y1 minus y2. If you plug it in the equation, you get 2 times 9.8 times 24, and that should be equals to around 22 meters per second is the velocity just before hitting the ground. Sorry, just before hitting the top of the spring. Then the C part of the problem, it says that the amount of the spring compresses, we need to calculate. So we again use conservation of energy. So we have location 1 represents the elevator just before the spring at this location when it starts to compress just before that. And the location 2 when the elevator is at the bottom of its motion, somewhere here. So this is location 2. This is location 1. Now, the level of the elevator just before striking the spring is 0 location. So this is our 0, 0 location. For both gravitational potential energy, elastic potential energy, and at this location, the velocity is 21.69 meters per second as calculated before. The value of y1 is 0 at this location. And at this location, the elevator comes to rest. Velocity is 0. But y2, is negative, which we need to calculate is less than 0. So we'll equate the energies at 2 locations. E1 equals E2 half mv1 squared plus mgy1 plus half ky1 squared. This is the total energy at location 1 is equals to half m v2 squared plus mgy2 plus half ky2 squared. So in this equation, we see and rearrange the equation, we'll get y2 squared plus 2mg by k y2 minus m by k v1 squared is equals to 0. So in fact, we see that we'll get v1 here. The y1 is 0, therefore this term is going to cancel. And there is no elastic stretch at this point, therefore this term is also going to cancel. And we'll get half v2 squared. This term is going to cancel as well. We'll have mg y2 and half k y2 squared. Divide everything by k, and rearranging, we get this equation. So we'll solve y2 by quadratic. So you'll get minus 2mg by k minus b, which is plus minus b squared, which is 4m squared g squared by k squared minus 4ac, but it becomes plus 4m v1 squared by g divided by 2. So this is a, this is b, and this is c. You got minus b plus minus b squared minus 4ac over 2a. So if you solve that and plug in the values, you will get y2 as negative. We must choose y2 as negative, and the only negative root for this, by plugging in all the values in this equation of mg, and v1, etc., you will get y2 as equals to negative 1.4 meters.